Hello students, today's agenda is to check homework. We'll be working on points on circles, although it includes other curves and other shapes also. And you will be working on 10.8. It says today students will be able to determine if points are on a curve and find missing points. So the first one in here is just because we have seen this in the past, right? This type of equation, and it's actually for a parabola, not for a circle. And so a parabola, remember, that has something like this. So this is the equation for one parabola. And so it says determine if the following points are on the parabola. Okay, so basically this is a point and it's just asking if it's on that line. Okay, and so how do we determine if these points are on the parabola? Well, what we're going to be doing is to actually, we know that this is x, this is y, and so all we have to do is replace that value in my x and y for the equation. And so it says y minus 3, so it's going to be 11 minus 3 equals 2 times x, which is 0, plus 2 square. 11 minus 3 is 8. And in here we do the parentheses first, according to PEMDAS. Parentheses, PEM, exponents next. Multiplication and division, whichever comes first. And addition and subtraction, whichever comes first. So parentheses first, so 2, 0 plus 2 is 2 square. And so the next one is exponents, not the multiplication here, but the exponents, which is 2 to the second power, which is 2 times 2 is 4. And so 2 times 4 gives me 8. Since they are equal on both sides, they have the same measurement or the same number. That means that this falls on the parabola of this equation. So we can say true solution. Okay, for the next one, we're going to do the same thing. I'm just going to use a different color so that we don't get confused, although there is plenty of space. But okay, so y is negative 11 minus 3 is equals to 2 times the value of x, which is 0, plus 2, and then square. Negative 11 minus 3 is negative 14. Remember that when we have something like this, it's addition of negatives. And so 2, 0 plus 2 is 2 square. So negative 14, is it equal to 2? Remember that we do the exponents first. So 2 to the second power means 2 times 2. 4. Is negative 14 equal to 2 times 4? Well, no, because 2 times 4 is 8. So we are going to say negative 14 is not equal to 8. Since they're not equal, we're going to put here false solution. It just means that the point is outside of the parabola. Okay? And we're going to do another one. Let me see if I can zoom out. Well, actually, we can see it here. So we have y is 35 minus 3 from the formula or equation equals 2 times x, which is 2, plus 2 from here, square. So now from there is just simplifying with PEMDAS. So 35 minus 3 is 32. Parentheses first, so it's going to be 2 plus 2 is 4 square. Then after the parentheses we do exponents, so this first we just bring down the 2, and then 4 square means 4 times 4, which is 16. Finally we multiply, so 2 times 16 is 32. Yes, they are equal, so we're going to say that this is a true solution. And I'm gonna write this equation down here just because I'm gonna put the paper up, and I don't want you to, well, I want you to see the equation. So it's y minus 3 equals 2 times x plus 2 square. Okay, so it's the same equation of the parabola. Okay, so the last point is 45 minus 3 equals 2 times the value of x, which is 3 plus 2 from here, and everything square, I mean that is squared. 45 minus 3 is 42, and here is 3 plus 2 is 5 square. 42 is equals to 2 times 5 times 5 gives me 25, and 42, well, here is 2 times 25 is 50, so they're not equal, so we're gonna say false solution. Okay, so that's what we have for all 4 points. We have 2 true solutions and 2 false solutions, and this, sometimes you're going to have only 1 true solution, sometimes you're going to have all true solutions, so it depends on the points that they give you. Okay, the next equation is of a circle. It says the following is the equation for a circle. Determine if the following points are on the circle. And I know this is not required for the homework, but if you remember, to find the center, you found the opposite of whatever was being subtracted or added to x, and here is nothing, so it's 0. The opposite of what is added or subtracted from y, so it's positive 3. And the radius, to get the radius, we would take the square root of the solution here, which is the square root of 169 is 13. So that gave us the information to be able to graph, which is the center, 0, 3. And then for the radius, you would just go 13 spaces this way, 13 spaces that way, 13 spaces that way, and 13 spaces that way. And that's where we would draw, whoops, our circle. Okay, I don't know if you recall from previous lessons. So now it says determine if the following points are on the circle. Do they fall in here? Okay, and they give us these points, and so we're going to be doing the same thing that we did for the parabola, but now it's for the circle. Okay, so let's start with the first one. We have x squared, so 0 squared, plus y minus 3, so 16 minus 3 square, is it equals to 169? So not including the square root, okay? That's, and remember, this is always x and y. And so 0 square is 0, so we're just gonna forget about that. But in here, 16 minus 3 is 13 square, and is it equal to 169? Well, 13 square is 169, so yes, it is 169, which means that this is a true solution. Again, when do we know that it's a true solution? When these values, if we replace x and y, they give me equal numbers on both sides of the equal sign. Okay? Okay, the next one is 5 squared, right? X is 5 squared plus, between parentheses, y minus 3, so the y is 11 minus 3 squared equals 169, and it's actually a question, not a statement. 5 squared is 25 plus 11 minus 3 is 8, and since it's positive, we're just going to put it square without the parentheses. You can put the parentheses if you want, but it's not necessary. And some people prefer to, if they're doing PEMDAS, to bring this down just 5 square. It's okay. I mean, I teach my students that if you have a plus or minus, that protects, and you can do the other parts in the middle. Okay, so a squared is 64 the 25, you bring it down, the 169 as well. And then 25 plus 64 is 89, which is not equal to 169. So we're going to say that this is a false solution. Okay, the next one is, can you see the equation? Okay, so it's 5 squared plus negative 9 minus 3 squared, is it equals to 169? 5 squared is 25 plus negative 9 and negative 3 is negative 12 squared. Is it equals to 169? We'll bring down the 25. Negative 12 times negative 12. Remember that in the square means that you're multiplying including the sign, so negative times negative is positive, and 12 times 12 is 144. Is it equals to 169? And if we add 5 and 4 is 9, 2 and 4 is 6, and you just bring down the 1, so it is equals to 169, so we can say, instead of writing it here, sorry, I'm going to put here, true solution. Okay, I'm going to replace this right here, and then I'm going to move it up. For the next one, the value for x is 5 plus 15 for the y minus 3 square equals 169. Since we already have it, I'm just going to cover that. It's okay. So 5 square is 25 plus 15 minus 3 is 12, since it's positive because of the greater value, is square. And guess what? It's going to be 25 plus 12 square is 144. And you can see the similarity, so it's going to be 169 equals 169, so this is also a true solution. Notice how for this one we have 3 true solutions and 1 false solution. Okay, the next example, it's asking for something very simple. It says the following forms a rectangle. Oh no, the following points, I guess, form a rectangle. Find the missing coordinate. So we are given 3 coordinates and we need to figure out what the 4th one is. So the first one is 2, 3. So 1, 2, 1, 2, 3. Remember that this is x always to the sides, and this is y up or down. The next point is 6, then 3. So 1, 2, 3, 4, 5, 6. 1, 2, 3. So both are positive, that's why it's to the right and up. Then here we have 1 positive and 1 negative. So it's going to be 1, 2 to the right because it's positive, but then negative 1 on y, so it's negative 1 right there. And you can see that in here we're finding the 3 coordinates for the rectangle. That means that it has to be aligned here. So that's going to be my 4th point to form that rectangle. And so what is that point? Well, I can count 1, 2, 3, 4, 5, 6, and then negative 1. 6, negative 1. So that's the missing point. Somebody in class said, teacher, but that's a square because it has 4 squares and 4 squares. I said that every square can be a rectangle, but not every rectangle can become a square. And the reason is because for the rectangle, the definition is 2 pairs of parallel lines, 2 pairs of parallel lines, and 4 90-degree angles. So if you can see here, this has 2 pairs of parallel lines. This is a pair, this is another pair, and it has 4 90-degree angles. So therefore, it's also called a rectangle. I share with the class that a square can also be called rectangle, It also can be a rhombus because the rhombus has 4 congruent sides and the squares has 4 congruent sides. It can also be called a parallelogram. Why? Because parallelograms the definition is just 2 pairs of parallel lines, and this has 2 pairs of parallel lines. And it can also be called a quadrilateral. Quadrilateral, the definition is just a shape with 4 sides, and it has 4 sides, so there you go. Okay, here is another one similar to that one. It says the following form a rhombus, find the missing coordinate. Again, similar to the other one. So it's going to be 3, 5, 1, 2, 3, 1, 2, 3, 4, 5, right here. 1, 2, 1, 1, 2. 3, negative 1, 1, 2, 3, negative 1. But now it's asking for the 4th coordinate. If you notice, a rhombus has to be symmetrical. So these are aligned. So now the other one is going to be aligned, and it's 2 spaces from here. So it's right there. So the coordinate to get there is 1, 2, 3, 4, 5, 1, 2. Okay, so 5 for x and 2 for y. As simple as that when it's asking for the 4th coordinate. Okay, so in here, and I hope I can have enough space in here, but in here we have 4 coordinates. It says prove the following is a rhombus. So we already said that a rhombus has 4 congruent sides or 4 equal sides. So let's find out. It says 1, 3, so 1, 1, 2, 3. And I'm going to put the coordinate here because it's not in exact order. So 5, 3, so 1, 2, 3, 4, 5. 1, 2, 3, it's right here. And I'll put the coordinate in a minute. And then the other one is 3, 4, so 1, 2, 3, 1, 2, 3, 4, right there. And the last one is 3, 2, so 1, 2, 3, 1, 2, right there. Well, you automatically can see that it does form a rhombus, right? But you need to prove, and to prove it, basically you have to show your work that you have. Let me see. I think I'm going to put this one down here just because I'm going to need the space for the work to prove it. So for this one, it was 5, 3. And for this one, it's 3, 2. Okay, so to prove that they are congruent, all you have to do is show that the distance from here to here, from here to here, from here to here, and from here to here, it's the same. And so basically, you're going to be using what you were using yesterday, which is the distance formula. So I'm going to start with these 2 points. And so the distance formula is equal to, remember, ojitos dormilones y coquetones. What does that mean? I just told them that they have flashy eyelashes and sleepy eyes because you have the minus in the middle. And in here you can have x minus x or y and y minus y, or you can have y minus y, x minus x. Okay, I usually use the distance is equals to the square root of y2 minus y1 plus x2 minus x1. So you can exchange the x and the y if you want to, and also 0.1 and 0.2 can exchange. However, if you change the y, you have to change the x as well. So that's something that you have to be very careful. I usually use this pattern because then we can relate it to the slope, which we'll be working on in the future. But okay, so in here, this is 0.1. so meaning x1 and y1. This is 0.2, meaning x2 and y2. And so it says that we're going to subtract y2 minus y1, so y2 minus y1, so 4 minus 3, and x2 minus x1, so 3 minus 1. And so I start, d is equals to the square root of 4 minus 3 is 1 square. 3 minus 1 is 2 square. Notice how in here I put a parenthesis and in here I didn't. It doesn't matter. If it's positive, you can leave the parenthesis or you can eliminate it. Okay? D is equals to the square root of 1 square is 1 times 1 is 1. 2 square is 2 times 2 is 4. And so the distance is the square root of 5. Okay? So that's for that part. Now, let's do it for these 2 points. So you're going to have 3, 4 and 5, 3. And you can exchange these 2 points. Again, this can be 0.2 and 0.1 or, okay? The order doesn't matter. So let's start with this one. Again, the distance is equals to ojos coquetones y dormilones, sleepy eyes. Okay, so it's going to be y2 minus y1. Notice how I do just so 3 minus 4, 5 minus 3. And so this is going to be 3 minus 4. In different signs, we subtract and leave the sign of the greater 1. So 4 minus 3 is 1, but then the greater 1 is negative, and that's square. 5 minus 3 is 2 square. If you don't want to leave the parentheses here, that's fine, but in here you have to have it because of that negative. And then in here, negative 1 times negative 1, positive 1. You are squaring the negative as well. And then 2 squared is 4. So d is equals to the square root of 5. Now I'm going to do these 2. So I'm going to put it up here. And the points are 3, 2 and 5, 3. And so I think I want to exchange them just so that to show you that well, that's fine. I'll leave it like that. So the distance is equals to the square root of ojos coquetones y dormilones. Aquí está, dormilones. So it's going to be y2 minus y1. So 3 minus 2. x2 minus x1. So 5 minus 3. And so d is equals to the square root of 3 minus 1 is 1 square. 5 minus 3 is 2 square. D is equals to the square root of 1 times 1 is 1. 2 times 2 is 4, which gives me square root of 5. Yay, 3 so far. Now we're going to prove the last one. And I don't know if I can see, this is the green color. Hopefully you can see it. So again, the points for that line is 1, 3. I'll put the big one here. 3, 2. I'll put this as 0.1 and 1, 3 as the second point. So this is x1, y1, x2, y2, and that just means the x and the y of 0.1, the x and the y of 0.2. Okay. So for the distance is equals to, I think I'm going to change color. Sorry, I was trying to keep it color, but and kind of, because this is not really blue. But you can't see it, so I'm going to use this blue one. Okay, so y2 minus y1 is, I forgot to put this first. y2 minus y1, so it's 3 minus 2, and 1 minus 3. So the distance is equals to the square root of 3 minus 1 is, 3 minus 2 is 1 square. 1 minus 3 is negative 2 square. And here, 1 times 1 is 1. And here, negative 2 times negative 2 is positive 4. And so the distance is equals to the square root of 5. So you can see that for all of them, the answer is square root of 5, square root of 5. And so, guess what? It is a rhombus. Okay? So with this, we're ending this lesson. And now you can work on 10.8. So have fun.